Okay, welcome to whoever's viewing this for our Developing on Amazon Web Services presentation for 665 e-business applications. I'm Sam Tucker.
I'm Forrest Kribs.
And I'm Ian Kane.
And today we're going to be going over the use of AWS for a multitude of development and other reasons used across 3 use cases. But first we're going to go into a little bit about the backstory of AWS. So what is AWS? We have talked about this a little bit in class, but pretty much it started as an extension of Amazon's services that they provide. It started mostly as a cloud storage solution. When it originally was conceived, it was just a place where people could store files and access them remotely through the cloud. But as it grew and as the services developed over time, it turned into more of an IaaS style, which is short for infrastructure as a service. The general idea is similar to how Amazon.com is a place where they want you to go and be able to buy everything without leaving the site. AWS is supposed to be a infrastructure where you never have to leave a browser. It should provide everything that you need within a single space, and that includes development, storage, security, all that good stuff. Specifically, one thing and a few things that are good about it is that it's generally cheaper servage and storage than owning your own dedicated servers. It's also slightly environmentally conscious if you're into that sort of thing. They try really hard for green initiatives, which we went over in a different presentation. They also really push a lot of automation. So a lot of companies have struggles with this when they own their own dedicated servers, whereas Amazon makes it really easy to build out automation scripts and make sure that things are up to date. The other thing that's really important is that it gives global access from one individual location. So having your own servers that are dedicated somewhere else in a different country or a different continent can be expensive, and that actually is something, the server physical location is something that actually is really important when it comes to games and game development. So for my use case, I want to talk a little bit about how game development is being used on AWS. As we talked before, a major thing that they're doing is automation. So a lot of game companies require a lot of space and a lot of dedicated resources for online gaming. The gamers who use these games get really frustrated when it's laggy or buggy or patches don't come out on a consistent schedule. So one thing that they can do now is that they can build specific instances of their game engines on dedicated servers that they access through the cloud. Which we'll get to in just a second. They also have automated rollouts of software updates, automated scaling of software when needed, depending on how many people are accessing the servers. And like I said, multiplayer games require dedicated servers to run at peak performance, but a lot of times those can be expensive. The specific use case I wanted to talk about today, before I skipped it, was a game that came out a few years ago called Evolve. So this game pits 1 player as a monster and 4 players as a hunter in a persistent multiplayer environment. As you can imagine, that takes a lot of resources on all sides. The processing power on the user PCs has to be very heavy and very strong, and then on the company's servers, there's also a lot of things going on behind the scenes there. So what they decided to do is using AWS, they decided to build individual cloud instances for the game. This way, whenever the players enter a new game together, they don't have to pull resources from specifically the disk it's on or the actual users' clients when it comes to their computers. This pulls as much processing and power into cloud as possible, and then has a much slower and smaller drain on a personal computer and latency, which also opens up PC gamers who don't have the most updated rigs to be able to join this game and enjoy it somewhat lag-free as well. And then, as stated earlier, a big thing that they were able to do is automate their servers to scale as well. So this chart on the right of the screen shows their kind of cloud infrastructure when it comes to how they automate these things. It's all in the cloud, but they still have multiple dependencies of these servers on their personal servers, built using Salt and MySQL. Both are regarded as modern systems administrations and engineering tools. But because they're using it through AWS, they can write really easy scripts that can increase or decrease the amount of servers and power that they're pulling from AWS up to 10% depending on needs. So I believe in the presentation that they had, they cited that if there's an over 80% capacity of their servers that are being used at any given time, they spin up more to make sure that it continues being a lag-free and easy enjoyment. But if there's a less than 60% use of their current servers, they power down 10% of them to save themselves costing. So in this way, they have a cost-efficient way to build out dedicated servers, which in turn provides a smooth gaming experience to the end user. So with that, after talking about how game development is used in AWS, my associate Forrest is going to talk a little bit more about a personal project that he's used in AWS.
Hello. So I'm going to be talking about how Amazon can be used to create a LAMP web hosting environment. As Sam mentioned, there's different services offered by AWS, and each one can perform a different role depending on what you want to be doing. For this example, we'll be using the compute section, the storage, and the networking in order to create a website on an Apache server that is then hosted by AWS and then stored on an AWS database. So AWS actually allows you to do everything that you need for web hosting, such as the network infrastructure. They will register the domain for you. They will host your server, and they will allow you to use multiple different versions of storage depending on your needs. So the first section that I'll be talking about is the networking section, which is Amazon's virtual private cloud. So this is where Amazon allots you a portion of their private network that you can do with what you want. By default, it is private, but also free. But then if you want to make it publicly accessible, you will need to pay for things such as a NAT, gateway, a public IP address, or a VPN if that's what you need. You can configure the network however you want, such as creating different subnets, routing tables, endpoints, and network security rules and access groups. So once you use the networking portion to create your virtual private cloud, you will want to use the compute services to launch an instance of an EC2 server. Each of these servers can be launched from the web portal, and Amazon will provide you with a lot of different configurations to customize to your needs. So for example, they have thousands of AMIs, which are Amazon Machine Images, which are basically ISOs or computer images that you use to launch a pre-built instance of a server. And then you can specify for that AMI the operating system and the type of Amazon server that you want. And Amazon categorizes their servers by type, as you can see in the first image on the left. And depending on how much you're willing to pay and how much processing power you want, they range from the T2 Nano to the T2 2X Large. So very, very scalable, and you can change that as your demand grows. Amazon's EC2 compute is used by very credible companies such as Netflix and NASA. So it's a very safe environment to work in. Lastly, you would need to use Amazon's web hosting storage platform, which provides various database options depending on what you need. So for example, they have their S3, which is their simple storage service. This is their most basic option. It's basically a flat file stored somewhere out on the cloud. This is if you want to use, if you want to create a dynamic, or a static website that just serves an HTML page. Other alternatives are the RDS, which is a relational model. If you look at the image, you'll see the different providers that they allow. So if you want to do a relational model, you can do that. And then there's the DynamoDB, which is a NoSQL environment, if that's the type of environment that you'll be wanting to work with. So lastly, I'm just going to tell you real quick how to put it all together. So you would create your virtual private cloud and then create a subnet for your database and the web server. And then you would configure the routing rules and security groups so that people can access the web server from outside of the network, but not the database. Then you would create a server. In this case, it would be a Linux T2 Micro. That's the free tier. And then you allocate it an IP address so that it can be accessed publicly, and then you would just connect into it and install your Apache service. From there, create your database instance through the web portal and configure it to have the tables that you want. And then lastly, register your domain through AWS, purchase your domain, and then point your records to that service so that the DNS will recognize where your server is located. So that's really the gist of it. That's how you would host a web server in the AWS environment. Obviously, there's a lot of different ways that you can do it, but that is a real-world example of using web hosting with AWS. So now I will pass things off to Ian to talk about the government side of cloud computing.
So Amazon Web Services is just one of a handful of providers, as we've talked about a little bit, for commercial cloud computing. And this is something that the federal government sometime during the Obama administration realized that it had the ability to and needed to try and modernize its IT infrastructure rather than maintaining a lot of its own, or all of its own, really, its own IT infrastructure, including servers, web hosting, email, databases, you name it. For the longest time, the federal government was hosting basically everything by itself. And there was a realization that this could be contracted out and it would be far more efficient in terms of cost savings, overall efficiency, and that's some of what has really changed in the last roughly 6 or 7 years. At this point, it's estimated that AWS provides about 80% of US government cloud services, which puts it just shy of $2 billion in 2016, 2017. That's expected to continue to grow more and more and more. There are specific GovCloud products, is what Amazon is calling it, and one of the primary drawbacks has always been for the government handling its own IT infrastructure has been related to security and intelligence and sensitive information and some of the specific requirements that relate to the handling of all of that stuff. And because of that, Amazon in particular, along with some of the other commercial cloud servers, but Amazon in particular has really made an effort to meet those same requirements that the government has always been able to meet of its own, and is at this point able to handle every single layer of classified material, which really puts it at least equal, if not much above, most of the other commercial cloud service providers. And so moving on to that has provided some opportunity for workarounds or just loopholes in what has traditionally been seen as some rather bureaucratic, red tape, lengthy federal acquisition regulations that have somewhat hampered the ability to innovate and work with industry partners for particularly in the defense and intelligence realm of government contract work for IT. One example being earlier this year in 2018, the Defense Information Systems Agency actually awarded a contract just shy of $1 billion to a subcontractor for Amazon to migrate everything from existing platforms to this new to-be-designed joint enterprise defense infrastructure. So moving on, that joint enterprise defense infrastructure is supposed to be a single award cloud concept for the entire defense industry. It's expected to be worth billions and billions of dollars over the next roughly 10 years. So there's a lot at stake for not just Amazon, but every company, big and small, that provides any sort of cloud computing, that there's just this one contract sitting out there. But because of the way that the entire IT industry works, the traditional sort of slow-moving federal acquisition rules really have kind of hampered some of those abilities, and it by the time that they can build something that meets what a contract says, it's far outdated, and so because of that, it's caused some federal agencies to try and find some of these loopholes. Ultimately, that particular billion-dollar contract that was issued earlier this year has been walked back and is somewhere just under $100 million because a lot of other industry partners did get very upset about it, understandably so. But some of the other things that have been considered is, as Amazon as a whole company is starting to, or is in the final throes really of trying to decide where to build its second headquarters, there is a lot of consideration for that same reason of having one of their possible locations be in the immediate Washington, D.C. area, because AWS is such a huge component of Amazon as a whole, and AWS does so much work for the federal government that not only would just physically being there be beneficial in terms of the actual latency and location of servers, but also just simple sort of lobbying and people-to-people sort of interactions that have that ability to make changes as regulatory environments could be changing for a company such as Amazon.
Great. Well, thanks, Ian, for us. So that brings us to our references page and also the end of our presentation. So obviously, Amazon Web Services and Amazon as a whole is a company that's really shaping the future of how we interact with the cloud in quotation marks. And it'll be interesting to see how they continue to develop. So we hope very much that you got to learn something from this and got to see how this is used in a multitude of institutions. And thank you for your time.